Hello, and welcome to this film, which is all about distinguishing strong and weak acids and bases. Now, hopefully by now, you've already got an idea of what we mean by a strong or weak acid or base. Here we're going to look at how the way these things behave when we dissolve them in water can allow us to actually tell them apart using a selection of tests. Okay, so just as a quick reminder of what we mean by strength, you might remember that substances, when we dissolve them in water, could do one of three things. They could either separate completely into ions, in which case we call them strong, whether they're acids or bases or anything else. They could They could separate partially into ions, in case we call them weak, or they could not separate at all, in which case they're non-electrolytes and they're not really of much interest to us in this topic. So bearing those things in mind, let's have a look at some tests we could do to tell strong and weak acids and bases apart. Now, first of all, we're going to look at conductivity tests. And these depend on the concentration of ions in solution. You hopefully remember from the bonding topic that if we dissolve an ionic substance in water and it breaks into ions, the fact that these ions can move around enables it to conduct electricity. So if we have a look at this experimental apparatus here, we've got a substance that we're trying to test. It's got two electrodes in it. We're trying to pass a current through it. And the more ions there are in solution, the better it's going to be able to conduct and the higher this current will be. Or perhaps if we use the globe here, the more brightly it would glow. So we might expect a strong acid or base, which separates into ions better than a weak one does, to conduct better. Right? So there's one test. We could use conductivity. We could also look at their pH. Now, pH is going to be something that we look into in a bit more detail soon, so I'm not going to go into this in a lot of detail now, but you might remember something about the pH scale. You might remember that it goes from small numbers to big numbers, depending on whether things are acidic or basic, and hopefully we can see that the stronger a base something is, the higher its pH is going to be. Weak bases will have pHs of greater than 7, but not as high as strong bases. And weak acids will have pHs of lower than 7, but not as low as strong acids, which will also be lower than 7, but towards this end here. Okay, so that's another way of testing them, is to measure their pH. We could also use their chemical properties. So everything we've looked at up until now, I suppose, has been a physical property, right? And it's talked about the concentration of ions in solution. Well, once again here, we're interested in the concentration of ions in solution, right? And the reason for that is, as we've seen in the chemical reactions film, when acids react with things, it's the H plus ions that are reacting. And the more concentrated those H plus ions are, the more likely they are to collide with other particles, and so the faster the rates will be. Okay? And considering that a lot of these acid reactions produce gases, it might be a good idea to use this fact if we're going to try and tell these things apart. So if I had two solutions, one of a strong acid, one of a weak acid, and say I put some sodium carbonate into both of them, I'd expect both of them to produce carbon dioxide, so I'd see fizzing in both cases, but I'd expect the strong one to fizz more vigorously than the weak one. Okay, so there's an example of a chemical test we could use to tell these things apart. Now, we might just ask ourselves the question before we finish, is this always going to be true? Is it true that the strong acid always reacts faster than the weak acid? Is it true that the strong acid always conducts better than the weak acid or has a lower pH? Well, that rather depends on the concentration of ions in solution. And the more concentrated your solution is, the more concentrated the ions will be. Now, that might sound like an obvious thing to say, but what we need to consider here is that if we had a very concentrated solution of a weak acid, so let's say 5 mole per litre ethanoic acid, that might conduct better than a very dilute solution of a strong acid, like maybe 0.005 mole per litre hydrochloric acid. So even though the strong acid splits into ions completely, the fact that there wasn't very much of it there in the solution to begin with means that we might have a higher concentration of ions in the weak acid solution because its concentration was higher to begin with. So when we ask ourselves the question, are these things we've been talking about always true? Well, yes, so long as we're comparing solutions of equal concentration. And bear in mind, we're talking here about the amount of acid that we put into the solution in the first place rather than the concentration of the ions that we end up with. Okay, so hopefully that all makes sense. Hopefully you've got an idea now of 3 different ways we can tell strong and weak acids and bases apart. If you've got any questions or comments, then please feel free to come and see me or to post a comment on YouTube.